Hello and welcome back everyone to the next episode on SAP Analytics Cloud Training with me Anubhav. In our last session, we talked about the concept of working with our digital boardroom. We have also seen how to create planning using value driver tree followed by the data actions. We have seen the collaboration functions also in planning in SSE. In today's session onwards, we are going to start with introduction to machine learning. We will understand the types of machine learning scenarios supported by SAP Analytics Cloud. We will understand also the intricacies of calculations, which is what SAP Analytics Cloud does behind the scene for our machine learning scenarios. But before we move on and talk about machine learning, let's also talk about a strategy for an enterprise to become more intelligent. SAP's vision is to make enterprises more intelligent. And in this journey of becoming an intelligent enterprise, there are contributors in terms of the softwares. So, who are the contributors in the journey for someone or a company to become a intelligent enterprise? Let's talk about that. So, according to SAP, an intelligent enterprise company would have these following features. In intelligent suite is the suite of technology which runs your core business functions, which includes customer experience, manufacturing and supply chain, digital core, which includes your finance, materials management, production planning, warehouse management, basically the entire ERP, followed by people engagement, network and spend management. So these are the suite of solutions today available provided by SAP in different verticals and line of businesses. But that's not enough for a company to be innovative or intelligent enterprise. The second component in this process is a digital platform. The digital platform allows your company to innovate faster. So on one side, you're running your company with classic softwares, solutions which are prepackaged with prepackaged content and standard functionality. But on top, as a customer, you would like to build a lot of custom functionality. And that's where digital platform comes into picture. SAP BTP or Business Technology Platform is a platform as a service provided by SAP to build solutions outside your digital core, yet remains connected. So there we can do data management and also the application management using the BTP platform that helps companies to quickly deploy new solutions without worrying about destroying their existing core. This feature is called side by side extensibility. The third ingredient is called intelligent technologies. Technologies which are built outside the core remains connected but on top of the digital platform. So this is how exactly three important ingredient together makes your company as an intelligent enterprise. In the process of digital intelligent technology, SAP Analytics Cloud is the one which plays a very critical role. So as far as SSE is concerned, SSE comes under the intelligent technology. There are more intelligent technologies which are independent solutions offered by SAP in the cloud to make your company run more digitally. Solutions, if you heard about SAP IRPA or SAP Conversational AI, chatbots, these are all different solutions offered in the cloud as part of intelligent technology stack. So this is also a certification question. What constitutes an intelligent enterprise? So it's intelligent suite, digital platform and intelligent technology. These three things constitutes to be a intelligent enterprise. Moving on, let's talk about the how decision making happens today in a company. So when it comes to decision making today, when a company wants to analyze massive data and take out some informed decisions, they will first start discovering the data. So typically a data engineer would go to the systems. They will collect and track all the data relevant for the businesses. Then a data scientist would analyze this data. To perform analysis on the data, the data needs to be brought from different sources to another system where it is being analyzed by data scientist. Then the data scientist will create prediction model on top of this data to drive some fruitful outcome. After that, there is a decision set of decision maker, basically CEO's office, which will act based on top of this data. After having an action plan, this action plan is distributed to the employees, and employees will then start acting on top of it. So if you see this whole complete cycle or the journey, there are different personas. Yes, there are different personas which are being used, and there are different developers which are also participating in this journey. So there are different people involved, different systems involved, different processes involved, and entire process is distributed across system and across people. Yes, in order to have a complete one-stop solution for doing all these activity in a single place, SAP Analytics Cloud provides such an amazing technology where it harmonizes your experience for data collection, analysis, and building the prediction, and also preparing the plans, because it also has planning feature to help your businesses to act upon the live data. Yes, so this is where Analytics Cloud comes into picture, which harmonizes your experience and bring everything together at one single place. So when it comes to SAP Analytics Cloud, we can also apply machine learning on SAC, and we can build multiple predictive scenarios on top of Analytics Cloud. So let me start first with the introduction to machine learning. Many of you are very new to machine learning technologies or machine learning in general. We will cover the basics of machine learning also as part of our training, as it was also a promise from my side that we will cover basics for those who are very new to the world of machine learning. So let's talk about what is machine learning. Before even we go into Analytics Cloud and understand something, we need to first understand what is ML. It is a that field of study that gives computers a capability to learn without being programmed explicitly. Wow, what a definition. So it's a field of study. Study means it is still undergoing through massive number of changes. People are applying, analyzing, and doing machine learning as a study even today. So it's a field of study, which means there is no concrete guidance, or there is no concrete proof that it will work 100%. It's still a field of study which gives computers a capability to learn without being programmed. So this is what machine learning definition is all about. Now, let me take a simple example to make it understandable for you. We all love movies, so you all watch Netflix, right? Netflix or Amazon Prime Video, or there are many OTT platforms where you watch digital content these days. Nobody is buying CDs to view movies and content, right? You are all going to OTT platforms to watch movies. So when you go and watch movies, some of you like different type of content. Some of you like drama, some of you like comedy, some of you like action. People like me like horror movies. Yes, some of you like documentaries. So when you go to these OTT platforms, you are typically viewing similar kind of content on regular basis. So like let's say one of the user of Netflix is viewing a content which is nothing but, let's say, fiction. Yes, so every time they are going and watching fiction movies, some of the people are, let's say, another person who is going and watching the animation content, animated movies, right? So next time, let's say last night I watched a horror movie on Netflix. Now, today morning when I opened Netflix, it was actually giving me recommendations on all the horror movies, the content which has horror inside, right? So, do you think there is somebody sitting in Netflix who is observing your viewing pattern and then preparing a separate or preparing a page for you which proposes you the horror content? What do you think, guys? Is there a employee of Netflix who is browsing and viewing your viewing pattern or your digital content consumption pattern and preparing a separate website page for you and publishing it to you? What do you think? Is it is it what is happening at Netflix? Are there Netflix employees sitting and watching each user what they're watching and then preparing the website page for them? What do you think, guys? Yes or no? What's your opinion? You can put it in the chat window. What do you think? No one? No one wants to answer? Of course not, right? So there is no one sitting in Netflix who is watching you or who is checking your what you're consuming and then preparing. So it's very simple, you just go to Netflix. So it prepares a simple page where it gives you the where it gives you basically recommendations. So Netflix recommendations. So you would see usually you get recommendations like this, yes, on the front page. So of course there is nobody sitting in Netflix. Imagine if Netflix has to hire people who should do this for giving you a personalized recommendation. How many employees Netflix has to engage? It will be huge cost for Netflix. So what Netflix does is they are actually doing machine learning. Sometime when you go to Gmail and you mark a email as a spam email, next time a similar kind of email comes, it automatically goes to the spam. How? Is there somebody sitting in Google who is viewing your mails and sending them to spam? Of course not. So that is also another example of machine learning where computer by itself learning and understanding what is categorized as a spam and it's sending it to the spam emails. Yes. So and that's basically Gmail example. Then Amazon. Last week I was having my mom's birthday and I was planning to buy a wristwatch for my mom. So I was browsing watches, but I didn't like something. Then I got an office meeting. After that, again, I was browsing other websites for watches. So the day yesterday, when I went again to Amazon, it was giving me recommendation for watches. How does Amazon know that I need to buy a watch? Yes, recommendation again. So there is something. So there is, of course, no employee in Amazon who is watching my browsing pattern, proposing me watches. No, it's the machine learning. It's the computer of Amazon which is analyzing my viewing pattern, my browsing pattern, and based on that, giving me suggestions. And that's what exact another example of machine learning in daily life you see. So now, if you see, does Amazon or Netflix hire a person to check our browsing pattern, to provide personalized recommendations? If yes, if yes, they need to spend billions of dollars to have a workforce doing the job, right? But that's not true. They don't do that. They don't have billions of people working at Amazon offices or other offices, right? So what is going on? So there is a machine learning algorithm which is responsible for doing the job, basically preparing a recommendation. So this saves time, effort, and money. for companies. That's where the machine learning comes into picture. It reduces human effort. Yes. So how exactly thing used to happen in the past? In the past, we used to give data and input to the computer, and computer have a program. There is a program written by developer. What computer now does is it gives you the output. Fair enough. This is what happens. In fact, most of the things today, it happens like this. What machine learning says is we will change this. According to machine learning, what happens now is you will give only the input and you will give expected output. What do you expect? And here is a computer which is having the ability to understand and give you a program. In short sense, or in a simple word, this program is called a model. What is it called? It's called a model. And it's not the model which you learned in Analytics Cloud. It's basically a machine learning model. So in this context, whenever you're talking today, we are talking about machine learning model. So today, whenever I use word model today in the class, please do not mix up with Analytics Cloud model. It's a machine learning model. It's a model which is understanding your input and preparing you next time the output. So it is the ability for computers to develop a special program or a special model through which next time you do not need to write any code to prepare some output. Yes. So this is how basically the basic idea of machine learning is. It's a field of artificial intelligence. So basically artificial intelligence is a very big area, so called AI, and it has many child areas, many sub areas. Like machine learning is one of the child areas under the artificial intelligence. Then we have robotics. Yes, we have face detection. Yes, we have voice detection. We have OTRs. We have extractions. So we have different fields under AI. AI is a big umbrella. Under the AI, you have machine learning as one of the field inside. So ML is one of the subfield under the artificial intelligence. So AI is the big umbrella under that ML comes. So we are not talking about AI. When I talk about AI, then I need to also talk about robotics and other things. Yeah. But we are just talking about ML, machine learning. So that is the main funda behind machine learning, where you will not code something permanently like in the past we used to do. Yes, and machine learning will provide you the result. So let me take a simple example to explain this process in detail. So let's take an example of a system which is basically marks and result. So last year in the university exams of, let's say, one of the university, let's say Carolina University, they have multiple students and these students have got marks. So let's say we put marks and we put here result. So last year 2021 there was exams conducted in Carolina in the university, and we had got these following marks, and then we have result. So this is pass, this is fail, fail, pass, pass, fail, and pass. So this was the input and this was the output. So someone human calculated based on marks, human have calculated, or a program was written which has calculated the result. Now, if we do look at this from the perspective of machine learning, what is going to happen here is we have basically this is the input. In this input, you also know the result. You know the output. Input and output you already know. You give it to computer. And what computer does? Computer will use some mathematical algorithms. Which algorithm? Right now we don't know. Let's assume we give it to computer. And what computer does? A computer applies machine learning. And machine learning identifies a rule. or a model based on this input and expected output. So computer did something, we don't know what it did, but it did something, and it come up with a model. And what that model says, so let me put that model over here. So what would that model say? What is the model it has come up with? It has come up with a model which says if the marks is greater than 4, then it's pass. As simple as that. This is the model which our computer has produced. Yes. So this is the model which computer produced. So now by producing a model doesn't mean that, okay, let's say it is greater than equal to 5. Yeah. So by the producing this model, we do not know, we do not guarantee that this model will work 100%. So what we do is we need to then again test this model. To test this model, what we do is we first give all the input data, we got the model, and now we will take the partial input data again. Yes, we will take this data again, and we know in this partial input data what is my input and what is my output. So one second, just I insert one more row below. So I say 5 pass. So this is my input and this is my expected output. And what I do is I suppress this time this output from computer. I will not pass this output to the computer. I suppress this data. I say this is a black box. I don't give it. Yeah, I don't give it. So black will not be visible to you. So I just do this. So now what I do is I just take the partial data which I use to create the model, and this partial data, some part of this partial data, I pass it back to this newly created model. So bring this model and I will suppress my expected outcome and I just give this input and I test this model. So when I give this data to this model, what model produce? Yeah. So what model produce? So if I go back, so I will then have the output by the model. Yes. So I have output by model. So this is my input and this is my output. So what the model says, if it is greater than equal to 5, so this is 5, it's pass. So this is now my output by model. Yes, let me put here orange. Yeah. So 5, okay, pass. Okay, 8 is also pass, greater than 5, 4 is fail, 7 is pass. So this is my orange color is my output by this model which we created earlier. And this is the data which we supposed to get. Now what you do is you will compare this blue area with this orange area. Yes, you will compare them. Yes, you will compare them, the blue area with this orange area, and you see how accurate it is. So if you compare, for the first record, it's pass and it's also pass. Second also pass, it's pass. Fail, it's fail. Pass, it's pass. So when you compare one by one, you find out that what was your expected output is absolutely matching with your output from model, which means your model is 100% accurate. Yes, this is the principle by which machine learning works. So in principle, you will first create a model and then you pass input and expected output to the model, and this expected output you suppress. You don't expose to the model, you just give the input, and then model produce its output. Then you will compare this expected output with the output produced by model to determine its accuracy. So in practical, accuracy can never be 100%, guys, remember. Yeah, it's a field of study. So accuracy will never be 100%. If accuracy is 100%, think about, we never had pandemic. If machine learning is so powerful, if it is 100% accurate, yes, we never had pandemic, we never had corona, because the data scientists would have predicted the scale of corona so early, right? But it's not possible, right? They didn't detect. Even today, nobody knows where the pandemic is going. Is it going to end or is it going to be there for with us? How many patients are going to be there? What are the expected life expectancies after the vaccination? Nobody knows. Yeah. So it is just something better than nothing. Something better than nothing. It's a probability. It is just going to give you a probability. It is going to tell you what is better than nothing. Yeah. So let's imagine we have got another model where this was the model. Now in this case, the first result will go to false, fail. So if you see out of 4 result, one of the result is inaccurate. So the actual value is pass, but the model says it's fail. So in this case, you know that this value predicted by model is incorrect, invalid. In such case, the model accuracy is 80%. So that is how the machine learning process also involved to determine the accuracy. So machine learning is not just determine the model. After determining the model, it also compares your results. It checks the accuracy of your model. That is also part of the process. So this input what you give over here is called validation data. Yes. And then with validation data, you will validate. Yes. And this is your validation data, and this is your output from model. This is predicted output. So your predicted output by the model is compared with validation data to find out the accuracy. And the initial data which you give is called training data set. Are these three terms clear to everyone? What is training data set? To create a new model, we give first the training data set. Then once the model is prepared, the output of the training data set is a model, is a machine learning model. Then we pass the validation data to the model. We get predicted output. So after that, we will determine the accuracy. So accuracy is a function of how good the predicted output is close to the validation data. Everybody clear? Till here, are you clear? Guys, please answer in chat window. Otherwise, it will demotivate me and I will just complete the class and go away. I will not ask any questions to you. Is this clear till here, everyone? Yes or no? Okay. So that is how the machine learning typically works. Now, let's go ahead and go to the next example. So this was a simple example. Now we need to understand what are the different ways to build this model. How analytics cloud or any team can create the model. Okay. So let's go and talk about model creation process or ML process. What is the process of entire ML? Yes. How exactly the processing happens in ML. So modeling is a process by which machine learning tries to find or create best possible predicted model for our use case. The model or the predicted model is created to predict an outcome. Model evaluation is an integral part of the model development process. In order to find the best model, we use mathematical algorithms. There are so many. There are so many. There are thousands of mathematical algorithms available today in the market. Yes. Also, there are some guidelines available with these algorithms when to use what, but there is no guarantee that which model gives you the 100% accuracy or close to 100%. Yeah. In order to find the best suited algorithm for our use case, The analytics cloud or any machine learning engine usage one of the following technique. One is called holdout technique. This is used typically when we have ample amount of data available. If you really have quality data, ample amount of data available, the accuracy of this technique is very good. The second is called cross validation technique. This is used when the amount or the volume of data is low. Amount of training data is low. So what is holdout technique? Yes, let's talk about holdout technique. So the holdout technique, according to holdout technique, the entire data set is divided into two parts. Like I explained few seconds ago, the first part is called training data set, which I showed you in the example. This was your training data set, which you used where you know the input and output already. Remember, you give input and expected output to the computer, and computer give you the rule or the model. Same thing. You give input and expected output to the computer, and computer give the model. Now we take subset of this data to validate if our model is good or not. Yes, that is what is happening. So we first part of this data set is called training data set, and second is called validation data set. So you divide the whole data set into two parts. With the help of training data set, we will train our algorithm to prepare a predictive model. Okay, to prepare a predictive model by applying our algorithm. So if we apply and then using validation dataset, we validate, yes, or we will determine the accuracy of our model. We repeat this exercise with a different predictive model until we get the desired accuracy for our scenario. So different mathematical algorithm will produce different models. Each model have different accuracy. So you will pick up the one which is the best. And this entire process is an exhaustive process. Yes, for humans. Yes, for humans, it's very exhaustive process. It's a time-taking process. Back and forth. It has to compute lot of computations is involved. So heavy computations. Hence, we need computers. Yes. Hence, we need computers to take over this work. And this is why it's called machine learning, because there is a computer, which is a machine, which is involved in this process, which is learning by itself and providing you the best desired results. Yes. This is the technique. Holdout is the technique. used by SAP Analytics Cloud for predictive model. So you will see in the training when we will build Analytics Cloud machine learning using Analytics Cloud, we will actually build a predictive model using this technique. Behind the scene, SSE will use this hold out technique, cross validation technique. When the data size is limited, to achieve an unbiased estimate model performance, we use cross validation technique. So when the data set is small, that's when it is used. We divide entire data into small chunks called key, and these keys are used for data sampling by grouping mechanism to calculate your model. So at runtime, system will create behind the scenes, system will create group of each pair multiple times to determine model. We will not learn this technique and we are not concerned about this technique because it is not our area for SAC. So Analytics Cloud use only the first technique. If also in interview or certification, nobody will ask you this cross validation technique in detail because it's not used in SSC. I just told you this out of curiosity, you know, out of just extra knowledge, but we do not consider this at all. Yes. But just in case, you should just remember that there is also another way to determine the model. But the one which is used in industry is number one, which is hold out technique. So in Analytics Cloud ML, somewhat similar to SAP other product IRPA? No. IRPA is all about automation. Let's say I give you a sales order screen and I ask you to create 10,000 sales orders. So will you sit manually and create 10,000 sales orders, Sandeep? No. What you do? You will record and replay. Yes, you will record and replay. So you will do a recording of the screen using the IRPA tool and then you will replay that. That's the automation. But if you do the same in a production system, then you are actually creating the sales orders. Now, what could be the use case? Imagine you get a quotation from your customer. Customer is asking you to purchase something from you. You got a quotation. Sorry, you got a performa from a customer. You got a requisition request, purchase request from your customer. Now, based on that request, you will have to create a quotation and send it to customer. So creating a quotation by reading the purchase requisition and determining the price of the product and discounts is a tedious task. But there are rules to do that. Everyone, humans will also use their IQ, their intelligence to determine the rules for discount and pricing. Yes. And then based on that, they prepare quotation. What if I say you don't have to do that? What if I say this repetitive task done by your staff can be automated? Yes. That's where the IRPA comes into picture. So these are two different, completely different areas. So think about it. If they are same, why would SAP create two different products for doing same job, right? Why would SAP create Analytics Cloud and IRPA as two different products if they are same job? They are not same job. IRPA is more about automation. Manually repetitive tasks are can be replaced by computers, like driverless car. Yes. Okay. Now let's continue now. So here is where we have the machine learning basics. We know the techniques. What are the types of machine learning? What are the types of machine learning? We'll go little fast now, guys. We are going very slow. This is just a theory, so I just wanted to take it as a theory. I could directly jump to Analytics Cloud if it's boring you. Guys, is the theory boring you? Is it useless? I can directly jump to SSE. We will directly upload data. We will prepare some output and I show you the output and I run away. What do you think, guys? Do you want me to stop theory and directly jump to the system and show you some output and go away? Is it important to go theory? Okay, okay, okay. Everybody says no, we need theory. Okay, then we will have theory, guys. So types of machine learning. There are three types of machine learning: supervised machine learning, unsupervised. I'm sure all of you have at least heard about this, and reinforcement learning. Supervised, unsupervised, and reinforcement learning. It's correct only. So what is supervised learning? Supervised learning where we train a model and we get a predictive model, then we validate the model, and then we will do a retraining. So as a data scientist, you are training, checking, and retraining. You are supervising the process. Manually, you're doing at least not entire process, but some part of the entire process you're doing manually, wherein you are training and retraining by as a data scientist. In this, the popular algorithm in this are decision tree, native Bayes, then we have logistic regression, we have linear or multi-regression, SVM. These are the different algorithms used. Why am I telling you this? Because these two algorithms are also used inside Analytics Cloud behind the scenes. Yes. So which scenarios in Analytics Clouds are powered by supervised machine learning? So there are two machine learning scenarios, which is regression and classification, which falls under this category. So in SSE, when we go, you will see regression, classification. These are the two scenarios which falls under supervised machine learning. Unsupervised machine learning. In this, let the machine work independently as a child to explore the huge data provided and come out with hidden patterns inside our data and build model. In this, the algorithms which are used are k-means, hierarchical, generic algo, time analysis. We have trend analysis. Yes. So these are the different algorithms which are used inside triple smoothing, which are used inside Analytics Cloud. So the one which are used in SSE are this and this. So if you remember few days ago when I taught you BI, in the BI we did a prediction of future sales based on a factor of time. So that time there was an option called triple smoothing. So it was basically using the unsupervised learning option. So the scenario which we use in SSE is called time series forecast. This is a scenario which is used in SSE to do the prediction as a unsupervised learning. Reinforcement learning, it is basically a candy stick approach where we ask machine to do some tasks and machine will come back with results. If the results are positive, we give a reward. If results are negative, we punish the machine. candy stick approach. So if you get good behavior, you get candy. If you have bad behavior, you get a stick, right? So this way machine will get trained based on so many inputs, and then it will improve on every iteration. Like it is used in robotics, where you train a robot by giving positive and negative feedbacks, and robot will improve day by day based on retraining. Yes. So now let's also talk about the difference between analytics and predictive analytics. So slowly I'm taking you to the analytics cloud now, where we will talk about scenarios specific to analytics cloud and how do we do these things in analytics cloud. So what's the difference between analytics and predictive analytics? Yes. So these are the questions which will be asked in interview. What's the difference between analytics and predictive analytics? So let's understand the difference really quick. So analytics is used to create visualization. Okay. It is used to create visualization on historic data that will just give us insight. So just get insights in form of charts, tables, yeah, different controls. This is providing as is state. Just get as is state. But predictive analytics is when we want to predict future. Remember again, is based on probability. You are not able to guaranteedly predict everything. Okay. So you are just want to predict the future based on probability, based on mathematical algorithm. We use predictive analytics. So predictive analytics gives us vision and direction where we are heading. So let's say if I look at 3-year chart of a share market stock, I would foresee that based on last 3 year share prices, what is the trajectory of this stock? Is it going up, applying, or is it going inclining or declining trend? So that's your predictive analytics. It gives you vision, it gives you direction. So when you put analytics and predictive analytics together, you get the vision. Yeah. So prediction will be done based on the past event and experiences of the future. So prediction is done based on past events and trends to predict future events. So it is extremely important to have a valid and ample amount or a clean data set to get better results. Guys, data is your new gold. If your data itself is bad or data itself is not sufficient enough to get the correct predictive model, the overall process has no significance. So that's why data itself is very important to choose the correct window of data set and the correct data set for building your machine learning model. Yes. Whenever you apply machine learning, before we apply machine learning, we need to ask 3 questions. What is my business need? What is my business goal? And what is output expected by the decision making? Any scenario you ever get in analytics cloud, always ask yourself these 3 questions. And based on these 3 questions which you ask to yourself, you will determine which machine learning scenario to use in SSE. So as I told you, there are 3 scenarios: classification, regression, and time series. So based on the need, goal, and expected outcome, we will determine which scenario to use. So let's start with the first scenario. in machine learning for SSC called classification scenario. What is classification? Have you also undergone through classification in school days? Yes. Do you remember in school days we are categorized by clans? Red clan, yellow clan. So on Fridays we wear a special dress, the colored dress in school. So we wear red, yellow, green, and blue. What is that? That's a classification. The school is dividing the students into groups. It's classification. Have you divided in classification in upper classes like meritorious student, average student, and backbenchers, right? Classification. So we are basically classification is about grouping. Okay. Let me take a practical scenario to explain classification in detail. So what is our scenario? So our scenario is I want to run a marketing campaign to attract to increase sales. But in order, but if you see in system, we have billions of customers. And if I run this campaign targeting all the customers, we will incur huge cost, right? If I contact each customer by phone or email, it's a big cost, guys. It's a very big cost. And I will likely to run out of marketing budget because budget is limited. Yes, you do not have infinite money with you. The budget is very limited. So you do not want to just pay and perhaps get a very less result. And it is very unlikely that every customer we contact will respond positive, right? Many customers will not even respond or they respond negative. Yes. So what is the challenge? The challenge here is to find out which customers respond positive and which respond negative against my campaign, my marketing campaign. And this should be done before you run the campaign. You need to do something to find out, okay, this customer will expected to respond positively and this maybe not, maybe negative. So if you can somehow predict, can somehow get probability of which customer have high probability to respond to your marketing campaign and which has low probability to respond, you will divide all the prospect customers in two groups. Yes, I call it as 1 and 0, as simple, black and white, true or false. Yes, so one which are likely to respond positive and which are unlikely or no response. And if I can find out the list of customers which are likely to respond, I will run my marketing campaign. So out of 1 billion customer, let's say I found 10 million customer which are likely to respond and remaining 90 millions are not. So I can easily run a marketing campaign only for those customers which are perhaps likely to respond. And that way I will save huge cost for my company. So the moral of the story in this kind of a scenario, when we want to classify our group of members, and guys, this is having a special term in the industry, is called population. So all the list of customers is a population for you. It's a population. So when you have a group of members, a population, and you want to classify this group of members into two groups, 1 or 0, which means binomial. In the previous episodes, I taught you data types. So there I also taught you the machine learning kind of data types. Please check back that lecture if you forgot. Binomial means either 1 or 0. Result is either 1 or 0. This type of problem is called classification. Classification. And the rule which is used is called classification rule. Yeah. So now next slide, I will make you understand what is the classification rule. So if you just wanted to kind of pictorially understand this, yes. So if I have group of members, it's a population, group of people. Let's say I have so many people. These are the people. This is the population. And if I now run something to basically divide this group of people into two parts, 1 or 0. So in this case, my result is binomial. So which rule, which algorithm, which technique do you use, guys, to do this? Which technique do you use? Which machine learning algorithm in Analytics Cloud you will apply if your result is binomial? Anybody? If the result is binomial, yes, you will use classification technique. Because classification's responsibility is to divide your group of population into two parts. Let me take another example. I'll ask you, you just say yes or no. Okay, I'll ask you scenario. You'll just say yes or no, whether you apply classification or not. I want to predict price of my house. Is that a classification problem or not? I want to predict price of my house. Is that a classification problem? No, it's not. Yes, so correct answer is no. Why? What is the output? When I want to predict price of my house, what is the output here? The house price, it will be, let's say, $600,000. So is this binomial? Is this 1 or 0? Is this result 1 or 0? Of course not. So how can it be classification? It cannot be. Yes. I want to predict out of 10,000 patient, which of the patient have corona, which of the patient have not have corona. Is that a classification problem? Is that a classification problem? If I want to detect coronavirus in group of patients, is that a classification problem? Yes, because you are having patients, 10,000 patients, you will classify which one have corona, which one not have corona, 1 and 0. I want to know the price of a share. I want to know what will be the share price of Microsoft after 6 months. Is that a classification problem? Is that a classification problem? No, because price of a share market, Microsoft share price will be a number. It will not be 0 or 1. So it will be like let's say $1349. That's a price. That's not, output is not binomial. So when the output is binomial, 1 or 0, only then you use classification. Is that clear, everybody? Hello? Yes or no? What is classification? Yes. Okay. So to predict price of the house or stock price, we have other scenarios. We will discuss them later. Now, let's go and talk about, and how do we determine, in case of classification, how do we determine the accuracy of our model? So now you know what is training data set, what is validation data set, what is actual output and what is predicted output. Yes. And you also know now the process, but how do we determine accuracy in case of classification model? We are going to take a break here for 5 minutes, and then we're going to start detail out the algorithm to determine the accuracy. How exactly SAP Analytics Cloud determine the accuracy? We'll take an example of a data set, and then we will try to understand first on the theoretical aspect, and then we'll go and apply this scenario in the in the system with Analytics Cloud Machine Learning. I'll be back in 5 minutes. All right, guys. So welcome back after the break. So before the break, we talked about the classification introduction, and now we're going to see how machine learning algorithm will determine the accuracy of classification scenario. So in order to determine the accuracy of the classification scenario, the first technique which Analytics Cloud we use is called confusion matrix. What is a confusion matrix? So point one, confusion matrix is not to confuse you. Yes, it is all about avoiding confusion of which technique is best for us. Yes, which technique is best for us? That is what confusion matrix is all about. In this process, we will compare our actual output with predicted output. Again, I would like to remind you what is actual output. You see, this is your actual output. This is your expected output. So for the first record, we were expecting pass, but machine gave fail. So this was your predicted output. You see, predicted output. And this was your validation data, your actual output. So I just, this is my actual, the reality. What is the actual output? What I expect. And this is the predicted output. We compare these two. Okay. We compare these two. To compare this, we will build a matrix, and that matrix is called confusion matrix. So it is all about avoiding confusion, which technique is best for us. So let's say you use 5 different algorithms and you got 5 different confusion matrix. Based on each confusion matrix, you can determine the accuracy. So it is a comparison between actual output, the reality, the real output versus predicted output, which is the probability predicted by machine learning. So let's see this example. Now I have an example for you. I went to my society and did a survey based on the health habits of tenants in my society. We predicted if a person is heart patient or not. We collected data of 200 people, out of which some of them were really heart patients. So Anubhav go to his society, he talked to 200 people and he collected data of their health habits. On the other side, my friend also who go along with me just ask each person, are they really heart patient or not? So Anubhav have now information about the health habits only, and my friend has information about how many of those 200 people are really heart patients. So after doing this sampling, we find out and we put all the output from machine learning and also the actual output where my friend have the information who is really the heart patient. We put them together. So we drive out a matrix. So let me put this matrix over here. So this is the matrix we drive out. So on this matrix, on one side, I put sampling of 200 patients and who are the actually who are the patients which are actual heart patients. One. Who are the patients which are actually not heart patients? Basically zero. Then I also went ahead and I got my output from machine learning algorithm. I did a machine learning based on their living patterns, based on their habits. We predicted has heart disease, heart patients. Machine is saying, okay, these are the heart patients, and then these are predicted not as heart patients. So machine predicted some people as heart patient and some not heart patient. That's what machine has predicted for us. And we put this data together. So we found out that there were 70 patients which were actually heart patients, and also my machine learning algorithm told me that these 70 people are heart patients. So my machine told me that these are heart patients and they were actually heart patients also. So these are the 70 patients. Then my machine also come up with result where it says 20 patients are heart patients. Machine said that they are heart patients by applying the machine learning model, but my friend told Anubhav these 20s were not actually heart patients. They were actually not. Yes. So we put them in this quadrant. And then machine predicted that these are the patients which are not heart patients, but they were actually heart patients. 30 people were under that category, where machine told me that they are not heart patient, but my friend told me that Anubhav, they were actually heart patient. Your machine is predicting incorrectly. Yes. Then there were 80 patients which were predicted as not heart patients, but they were also not actually the heart patients, which means machine is also predicting non-heart patients correctly in this case. So if you see the first quadrant, they were actually heart patients and machine also predicting them they were heart patients. So these are called TP, true positives, which means all the positive targets correctly predicted by machine. Yes. So 70 patients were actually heart patients and machine also found them out that they are heart patients. Then 20 patients were actually not heart patients, but machine is telling me they are heart patients. So this is false positive FP. Then you have patients which were actually heart patient, but machine says they are not. They are false negative FN. And there were 80 patients which were actually not heart patients. And machine also told me that Anubhav, they are not heart patients, which are true negatives. Can anyone tell me if my machine learning algorithm is very good, where should your count increase? What is the ideal scenario? Where should be your count increase? Quadrant 1, quadrant 2. If your machine learning algorithm is good, what do you expect? Which quadrant you should have more data? What do you think? If your machine learning algorithm is very good, which quadrants or quadrant should have more data? If your model is good, good quality model, which are all the quadrants you should have good data? Number 2 and 3, wrong. It's opposite. It's number 1 and 4. These are the green quadrants. You see true positive and true negative, where machine is correctly predicting. See here 0. They are actually 0 and machine also predicted 0. So 0 0 matching, quadrant 4. 1 1 matching, quadrant 1. Is it clear to everyone that they are actually heart patient and machine is also telling me that they are heart patient? So machine is working as expected. Computer is predicting me correctly that they are heart patient actually, and machine also told me that they are heart patient. So what is the job of machine learning? Is to predict correctly. Is to predict correctly. That's a job. Don't look at heart patients. Look at machine's job. What is machine's job? To predict data correctly. So what is actual? Is machine also telling me that it's actual? It's close to actual. So wherever it's close to actual, it's better results. So you see, 70 patients were predicted correctly. 80 patients were predicted correctly. 20 patients and 30 patients were predicted incorrectly. Is this clear to everybody? Is this clear to everybody? Yes or no? Anyone has any question, please ask me. If it's not clear, please ask me. Why should we add more data? We should not add more data. We just calculated here, and we want, if our algorithm is good, we should, the machine should increase this. This count should be increased. If our algorithm is good, quadrant 1 and 4 should have higher count. That's a better algorithm. Yes, that's a better algorithm, which means if today you have five algorithm, if you have five different algorithm, 1, 2, 3, 4, 5, which algorithm you will decide to choose for your scenario? Which algorithm? So Nochango, it's a question to you, Nochango. Which algorithm you will decide to choose? If you have five different algorithm, which will lead to five confusion matrix. Yes. So this confusion matrix 1, it will lead to confusion matrix 2, confusion matrix 3, and confusion matrix 4, and confusion matrix 5. You have five different algorithm and you got five different confusion matrix. So Nochango, which confusion matrix or which model will you choose based on confusion matrix? The model which has higher values in number 1 and 4, that is accurate model, more accurate. Because look at the actual and look at the predicted. They must match. So higher the value in quadrant 1 and 4, better the results. So let's say assume number 3 is having higher value in quadrant 1 and 4. So I will choose this one as my correct algorithm. Everybody clear? How do you decide? Everybody
So
clear? Yes or no? How you decide? So you have five confusion matrix. You will see which confusion matrix has higher values in 1 and 4 because they are correctly classified information. Yes, they are correctly classified information. So these are the ones you will choose. Everybody, are you clear? Yes or no? Yes or no? Is this clear? Okay, I assume it's clear. Let me proceed further. So now we have got true positive and true negative. We want to increase that count. Now, based on this confusion matrix, we also derive some formulas. These formulas will help to identify the accuracy of our model. So what are these formula? The first formula is called sensitivity. So these are the things which you will see in Analytics Cloud in few minutes when we will do our scenario. What is sensitivity? So what is sensitivity? Sensitivity is equal to true positive divide by true positive divide by true positive plus false negative. So you see TP divide by TP plus Fn. You see that's your formula for sensitivity. That's your formula for sensitivity. TP divide by TP plus Fn. That is the first formula coming on your screen. Sensitivity. Then comes is specificity. Specificity. This is the second formula, and this formula is false positive divide by false positive plus true negative. So FP. So basically this divide by sum of these two. Yeah. So false positive and true negative. This is called specificity. Specificity. Yeah. Specific. Yeah, it's correct only. So sensitivity and specificity. What they identify? They identify how many percent of positive targets predicted correctly. That machine is able to predict out of my total positive targets. So you see, they were true positives. They were actually heart patients. So out of actual 100 heart patient, machine predicted 70 patients correctly. You see, 70 out of 100. So actually there were 100 true heart patients. You see, the actual positives. 100 heart patients were actually there in the data set, out of which machine predicted 70 of them correctly. So that is the percentage. So it's 70% in this case. Then comes is how many of the negative targets incorrectly predicted. How many percentage of negative targets were incorrectly predicted? That is your second rule, specificity. Yes, sensitivity and specificity. The sensitivity is also known as TPR, true positive rate, and specificity is also known as FPR, false positive rate. TPR and FPR, true positive rate and false positive rate. Remember, these formulas will be asked to you in interviews. In interviews, somebody will ask you these formulas. Then comes is the next parameter. This parameter is called as precision. What is precision? Precision is true positive divided by true positive and false positive. Yes. How many of the predicted target are actually correct? How many percentage of predicted target are actually correct? That's that's called precision. Yes. Then comes is fallout. So the formula here is true negative divided by true negative plus false negative. How many of the predicted negative targets are actually negative? Yes, how many percentage of predicted negative targets are actually negative? So this is called fallout. These are the formulas which we calculate TP divided by TP plus Fn, FP divided by FP plus Tn, precision and fallout. Then comes is accuracy of the model. So accuracy is predicted by true positive plus false positive divided by true positive plus false positive plus true negative plus false negative. That is called accuracy of your model. So these are the formulas which we use based on confusion matrix. So next time when you apply, let's say, 5 different algorithm, you get 5 different confusion matrix. For each of them, these formulas will be calculated, and these formulas will determine how good your model is. And based on that, analytics cloud will choose the most suitable model for your scenario. And this all happens behind the scene. You see, there are a lot of mathematical calculation involved, and they're all done by computer. You don't have to do it, but I'm just telling you behind the scene what computer does. That's what I'm telling you, behind the scene what computer does. Now think about, if we have, let's say, 10 different model, we get 10 different confusion matrix. If you have 50 different model, we get 50 different confusion matrix. Now think about how many confusion matrices you will get. You will get so many of them. It is very hard for humans to analyze all these confusion matrix. Yes. So that's where what SAP does, they will also create a plot. They will create a chart between TPR and FPR. Okay. How does SAP create this chart? To explain this chart, let me explain you a scenario of logistic regression. Okay. I will take a scenario of logistic regression where I will actually put the same example of heart patients. So we will have total 8 heart patients, or total 8 patients which we analyze, and based on whether the patients are obese or not, we have determined the confusion matrix. So let's see an example. of confusion matrix. So we have analyzed. So now I'm just taking this scenario to next level where I'm taking small data set and explaining you how behind the scene all the calculation happens so that you can understand that confusion matrix from confusion matrix what we drive actually. So we have analyzed 8 patients and based on if they are obese, obese means fat or not, are they heart patients. So out of these 8 patients, 4 were actually heart patients and 4 were not heart patients. So we put them on a chart based on their weight. So general term is if someone is heavyweight, if someone is more obese, they are likely to have heart disease, correct? So someone have 100 kilo, 120 kilo is expected to caught by heart disease. Someone who is lean, just 50 kilo, 52 kilo is not expected to have a heart disease. You know, heart disease is connected to the weight of the people. So we put these 8 data points. Each data point which is actually heart patient is marked as in the blue color, and the patients which are not not heart patients are marked in red color. So the blue data points are not heart patients, sorry, are heart patients, and red data points are not heart patients. Okay, on this chart. So now you see, this is an algorithm. This is called logistic regression. It's an algorithm, mathematical algorithm. We are just taking it as an example of algorithm. Let's say I use logistic regression algorithm. So it's a logarithmic curve between x-axis and y-axis. So you see the x-axis is weight of the patient. Yes. And y-axis is the probability of whether the patient has heart disease or not. If a patient comes under close to 1, it is likely to be a heart patient. If a patient is close to 0, it's not likely to be heart patient. And you see these are the patients. So you see this patient, this one, let's say Alex is having this weight. And if you just take Alex and try to intersect our chart for Alex, you will see if I draw a straight line here, what do you think? Alex is heart patient, likely to heart patient or not? Yes, you see, is likely to heart patient because it's coming here close to 1. And this is Alex, let's say. Now let me say Sam. What do you think? Is Sam a heart patient? Likely to heart patient or not? Sam, you see, cut here. It's coming close to 0. 0 is not likely to heart patient. So Sam is predicted to be not heart patients. So this is your model. This is our prediction model, which is a logistic regression. By intersecting these points, we will determine whether this patient is a heart patient or not. So that will be my predicted output. But what is my actual? Actual is this blue point and red point. The red point indicates that this person is not heart patient. Blue point indicates that this person is a heart patient. Now you see here these two people. Let's say people A and person B. Person B, if you see, is actually not a heart patient, though he has more weight than A. Yes, B has more weight than A. Machine says that B is a heart patient, but he's not. But point the person A is actually a heart patient but has less weight. How? Because person B is a bodybuilder. He's having more weight, but it's more muscle mass. But person A is not a bodybuilder. He's just having weight and it's a pure fat. So that's why he is heart patient. So you can actually see over here the red and blue, they are actual data. But when we draw a line and intersect this with our predictive prediction, this is our predictive model, we will determine the prediction whether they are heart patient or not. Yeah. So now what I'll do is I will draw a confusion matrix based on this data. Yes. And to draw a confusion matrix, what we do is we take a threshold line. So let me take a threshold line at let's say 0.5. So now I will just have a threshold line and I'll put it at right now 0.5. So anyone which is going beyond 0.5, yes, beyond this 0.5 will be considered as heart patient. Yeah. So let's put this line right now. So if I keep my threshold as 0.5, let's say threshold is 0.5, what will be my confusion matrix? Let's draw the confusion matrix, guys. If my threshold is 0.5, so I come and I use my pen to draw the confusion matrix. You guys will help me, okay? Help me, guys. If you really want to understand this scenario, try to help me. Don't ask question right now. Try to just help me. This is how we write confusion matrix. So actual 1, actual 0, predicted 1, and predicted 0. So we have total 8 patients. You see 8 data points. The blue ones are actual heart patients and the red ones are not heart patients. So now let's see. We will do one by one for each patient, and let me draw a perpendicular line now. So let's talk about this guy. He is a heart patient. He is actually a heart patient. Machine is also telling it's a heart patient. Why? Because it's above this line. Anybody above this line is a heart patient according to machine. Yes. So do you think machine is predicting correctly this data point? Do you think machine? Yes, because he's actually heart patient and machine also says he's a heart patient. Now move to this data point. He's actually a heart patient. Do you think machine will predict him correctly that he's heart patient? Yes. You see, it's above this line. Intersection is above this line. Then machine is say yes, he's a heart patient. Now move to the next one. This is also a heart patient. Do you think machine will predict him correctly that he's a heart patient? And he's actually yes, he's actually heart patient, and machine also says yes. Now look at this. This guy red is not a heart patient. But what machine is telling? Machine is telling he's a heart patient because he's above the line. You see, intersection is above the line. So when you see the intersection is above the line, here you see it's above the line. Machine will tell you he's a heart patient. Now, if you do this here, this one, so he's not a heart patient. Machine also says he's not heart patient. But for this data point, he's actually heart patient, but machine will say he's not heart patient because he's below the line. So when I take threshold as 0.5, machine is predicting me. So for 0.5 as a threshold, how many patients are predicted correctly as heart patients? So you see, there are 3 patients which machine says, you see, this one, 2, 3. They are actually heart patients and machine predict them correctly. But you see this guy, number 4, this guy, he is a heart patient, but machine is telling he is not. So he is actually heart patient, but machine is predicting not. So that is one person below the red line, which is actually heart patient, but machine says no. Yes. Similarly, if you see this person, he is actually not a heart patient, but machine, since the intersection is above the line, machine will say he's heart patient. So machine says he's heart patient, but he's actually not. And then you see the remaining 3 reds, they are below the red lines. They're intersecting below the red lines. They are not heart patients, but machine also says they are not heart patients. So machine correctly predicts the non-heart patients, 3 of them. Total is always 8. 3 1 3 1, total is 8. Total 8 patients are there. Okay. So in this case, this is one confusion matrix if we keep threshold at 0.5. Yes. Now let me change the threshold. So I go back and I change threshold to 0.2. Now let's see. Now let's see. When the threshold is 0.2, this blue will be predicted as heart patient. This also predicted as heart patient. This also predicted heart patient. This also predicted heart patient. This also predicted heart patient. This also predicted. So all these data points are predicted heart patient, but out of these, 4 are actually heart patient, but 2 are not heart patients. But they were also predicted as heart patients. Yes. Then the ones which are these two, they are not heart patients. They are also predicted correctly that by machine that they are not heart patients. So if I put threshold as 0.2, what is my confusion matrix? What is my confusion matrix? Let's draw the confusion matrix. So total 8, actual 1, actual 0, predicted 1, and predicted 0. So you see there were actually 4 patients. All 4 were predicted as 1. You see this one, predicted 1. Anything above the red line, predicted 1, predicted 1, predicted 1. So all the 4 patients, which are actually heart patients, they were all predicted correctly. How many heart patients were actually there which were predicted 0? It's 0. Why? You see, there is no blue point below the red line. You see, this is your red line intersection. There is no one below the red line, no blue point below the red line. All the blue points are above the red line, which are predicted 1. Predicted 1. Anything below this, predicted 0. So you see, all 4 were correctly predicted. Then if you see here, how many are actually not heart patients but they were predicted 1? So you see, all the ones which are red points above this line. So there are two of them. And then how many of them below the red line which are red points? There are 2. Again, total is 8. So in this case, you see, your true positives have increased. Last time your true positive were 3, now it is 4. Yes. And in this case also, your true negatives have reduced. Yes. Your false negatives have increased. Yes, false negative have increased. So it depends on different threshold. We will drive different confusion matrix. So if it is absolutely essential to predict all the patients correctly, we will keep the threshold to 0.2. Let's say these are corona patients, not heart disease patient. If you not predict any corona patient correctly, and if that person goes out in the market, there is a chance that he will cause an outbreak. So it is absolutely essential that if it's a corona patients, we predict all the positive targets with higher accuracy. So in case of coronavirus patient, I will use my threshold value 0.2. Yes. In case of heart disease patient, it's okay to keep the threshold value 0.5. Are you guys understanding? Yes or no? It is just a game of playing with the threshold value. Different threshold values will produce different confusion matrix. Is this clear till here? Yes or no? You can try yourself at home. Watch my video and try yourself to draw confusion matrix on this chart. Okay. Watch my video again and draw this confusion matrix yourself on this chart. Okay. So now if I put threshold as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, we will get different confusion matrix. In total, how many confusion matrix you will get? Can anyone tell me from this entire chart? How many confusion matrices you will get in total? If you put different threshold? Yes. 10 confusion matrix. When you put threshold as this, for each point, for each line, you will get different confusion matrices. So you will get total 10 confusion matrix. I would request you to try this at your home. Try yourself at your home, put different threshold, put this data point and try to get confusion matrix. Yeah. So you will eventually get so many confusion matrix. You can see I have drawn already these confusion matrix for different threshold over here for you. For 0.1, 0.2, 0.3, 0.4, 0.7, 0.8, 0.9, 0.1. So I've drawn all the confusion matrix and I've also determined the TPR and FPR, sensitivity and specificity. You see 1 to 1, 1 to 0.90, 1 to 0.75. You can try yourself. Try yourself at home and drive TPR and FPR and calculate confusion matrix. This is a homework for all of you. Okay. So now you've got many confusion matrix for different threshold. It is hard to read each confusion matrix for user. Correct? If I put all these confusion matrix in Analytics Cloud, do you think our user will understand? Do you think our user will understand? If I put all this data to the user, will they accurately understand which model to choose? They will not. They will get confused. Yes. So that is why, guys, we have now a plot between TPR and FPR. So what I'm going to show you now, I'm going to draw a chart between TPR and FPR. Yes. And this chart is called ROC curve. So what is ROC curve? It's called receiver operating characteristics curve. Yes. Also known as ROC curve. It's a chart between your TPR and FPR. Okay. Because since there are large number of confusion metrics, and it will be hard to analyze them by user. We don't want to overwhelm our user with the number of confusion metrics. So we can draw a curve between TPR and FPR to better project model accuracy. So undoubtedly, confusion matrix is the best way to determine the accuracy of a model, but a large number of confusion matrix will cause a confusion for the user. So it is better to draw it in a chart. So let's try to plot a chart between TPR and FPR. I try to plot a chart between TPR and FPR. So on x-axis, we will take the TPR, and on y-axis, we will take FPR. So this is TPR, true positive rate, and we will put FPR, false positive rate. Okay, so now if I plot, this is 1, this is 0, this is 0, and this is 1. Fair enough? So let's draw a plot now based on confusion matrix. So first point is TPR FPR 1 is to 1. Okay, when threshold was 0.1, TPR FPR was 1 is to 1. So where is the point 1 is to 1? It is this one. This is TPR 1 is to 1. So let me use my pen only. Okay, guys, I will take a screenshot of this. That's better. I will put my screenshot on the left. I'll put my slide on the right to draw this chart. One second, guys. I'm just adjusting everything so that we can draw it side by side. It's not taking. Just give me 1 second. I'll take this image from here and put this image here itself. Make sense? And let's draw a chart. So our first data point is, you see, 1 is to 1. Yes. So we will plot 1 is to 1. So my first data point is 1 is to 1, where TPR is also 1 and FPR is also 1. 1 is to 1. This is when the threshold was 0.1. When threshold was 0.2, you can see TPR is still 1 and FPR is 0.90. So let's come here. TPR is 1, FPR is 0.90 for threshold 0.2. Then if you go next, when threshold is 0.3, TPR is still 1 and this is 0.75. So it comes like this, 1, 0.75. So you see TPR is still remaining constant for all these three thresholds. TPR is very good, but false positive rate is coming down. Yes. So earlier false positive rate was 1, then it came to 90.75. Yeah, it's coming. False positive are coming down. Okay, next, when the threshold was 0.4, it is 1 comma 0.5. Then next is when it is 0.7 threshold, it's 0.75 and 0.25. So it has come here 0.75 comma 0.25. You can see TPR is 0.75. You see this is 0.75, somewhere about 0.75. This is zero point 0.5. This is 0.25. Yes, this is 0.5. This is 0.75. This is 0.90. This is 0.25. Yeah, this is 0. So this has come down. If this time TPR also come down, then we have next 0.75 and 0. So it has come over here 0.75 and 0. FPR becomes 0, TPR becomes 0.75, then 0.5 and 0. So 0.5 and 0. Then we have 0, 0, 0, 0. So you see this is your curve. Now if I join all these data points together, I get a curve. I get a curved line. So let me join all these data points together. Yes. So this is the curve which is called as ROC curve. Everybody, are you clear what is ROC curve? Till here, are you clear what is ROC curve? Receiver operating characteristics curve. Yes, it's a curve between TPR and FPR. This is called perfect model. Okay, if your model is this, it's called perfect model. But typically, this is called ideal model. But the model, when you actually apply machine learning in analytics cloud, model will not come like this. Model will come something like, sorry. So model will not come like this. Model will come something like this. Sorry guys, there's some problem. I should use a different. Yes, this will be model. Or when you do again, this will be model. So your model will not be always perfect, but it will be something like this. You see this one. I want to change color. Yeah. So you see this one. This one will be one model, and this one will be another model. So you see there is a green, there is a this one. There are different models. So every algorithm will produce a different AUC and ROC curve. Now my question to you, if let's say I call my green line as model number one, model number one. Yeah. Let's say this model I will call it as Spider-Man, and this model is Superman. Which model according to you is better? Superman or Spider-Man? Which model is better? Spider-Man. Why? Why Spider-Man is better? Because it is more close to perfect model. Yes, this is your perfect model. So it's more close to, and also you see it is more close to TPR. For Spider-Man, TPR is higher, and for Superman, TPR is lower. True positive rate. You remember what we want to increase? We want to increase to positive rate. TPR. Quadrant 1 and 4, as good they are for us, it's better the accuracy. You see, it's proportional to TPR. Yes. So a model which come closer to the perfect model or has higher TPR is better accuracy. But a model which is not close to the perfect model comparatively is bad model. So if I apply two different algorithm, Spider-Man algorithm and Superman algorithm, I plot a TPR and FPR curve, ROC curve, and I will know that Superman model is better than Spider-Man model is better than Superman because it's more close to perfect model. Now, there's another parameter. It's called this parameter is called AUC. So you see this area under this curve, this entire area. Yeah, this entire area. This area is known as area under curve, AUC. So guys, tell me which model is better. Which model is better? You will rate which model better, where AUC value is higher or AUC value is lower. Which model is good, which is bad, according to you? Area under curve is higher the good for us, or area under curve is lower the good for us? This is good. This is bad. Why? Look at the Spider-Man. Spider-Man area under curve is little extra. Do you notice this? So for Spider-Man, this is extra. So area under curve for Spider-Man is more than Superman, and we already identified that Spider-Man is better. So higher the area under curve is better the model because it's far from the FPR rate. Look at this. We want to go away from FPR. So higher the area under curve, you are more away from FPR. Are you clear? Everybody, are you clear? What is ROC curve and what is AUC? What is confusion matrix? Yes. So this is our basics of machine learning. In the next episode, I'm going to show you a scenario for classification, and I'm going to take you to the system with a classification scenario. And when we run the classification scenario in Analytics Cloud will create and predict everything. All of this will be created by SAC for us. So tomorrow's class, before you come, please read through today's lecture again. We will upload the video today faster in another 3 hours. So please go through today's class video again if you want to be confident in tomorrow's class. Yes, I know it's new thing for you. It will take time to digest. Go through the video again. I'm done with today's session. Time for your questions.
Sir, the question is not relating to this. Question is relating to the planning model.
Uh-huh.
May I ask? So, in currency table, we uploaded each field by copy and pasting it from Excel file to the model, currency model.
Mhm.
Can we directly upload the full Excel file? Is there any method?
No, we cannot. Individual dimensions needs to be copied manually. We cannot.
Okay.
Mhm.
Thank you, sir.
Okay, so
Hi,
please,
Anubhav.
yes, go ahead.
Anubhav, I have a question, Anubhav. Anubhav, like I am building the proof of concept for my company, yes, and I taking some data from like the month of July, yeah.
Mhm.
And now every month I am doing manually this part, yeah.
Mhm.
So is there is any process is there such that I can automate? But I know this Google Drive, the process which you explained me, yeah. But
Mhm.
according to the rules and guidelines, I don't have to use the Google Drive.
So you
So
can use a
what is
data
the
source like
another?
BW or S4HANA.
Mm-hmm.
That is also fine. You can use data source instead of Google Drive. So when we will
So I
read
have.
to one
Mhm.
chapter where we'll talk about live data connection and also quad
Okay,
data connection from S4HANA, that time this question will be answered.
okay, okay,
For
Anubhav,
data update.
this question
For data
is
update.
data update. Okay, okay.
Yes.
Anubhav, second question is that no, I build the stories, yes, but my story is distributed into different countries in Europe. Yeah. So my example, Germany, Switzerland, France, and Italy and Austria, this country. But when I give my user story to the user, I want that the another user sitting in Germany, he cannot see the data from another country, yeah? Like
Mhm.
an authorization depending upon the sales organization.
Mhm.
How can I define this way?
Okay. So this comes under a security. So I take your point. Usually this is not covered in my training, but let me just explore
Mm-hmm,
one scenario for you. a short and small scenario, and try to build a scenario in my productive system, because this will require, user play with users, and in trial account we are not allowed to play with users. So give me some time. I noted it down, your question,
Okay.
and I will try to build one scenario and come back to you.
Okay. Anubhav, the last question is, do the business user also needs SSC account? Like I build the stories and now I have to give the stories to my business user. Do the business user also need the SSC account?
uh, do the business user also need SSC account? No. They, what usually the security people does is they do a configuration with IDP. IDP stands for identity provider. So they will do a
Okay.
secure relationship with IDP. Now, just I take a simple example. Imagine in your company, you have 30 or 40 different softwares. Yes. So you have Outlook, you have S4, you have company portal, you have SAC. Does your user need to remember password for each software? What do you guys do today?
We use a
SS,
key pass.
isn't it? So when you go
Yeah.
to access Outlook or any software, it will redirect you to login on your company portal. Yes, SSO. Yes, and this SSO have a trust relationship with all these softwares behind the scenes. This is called IDP, identity provider. Same for SSE. You will go to the business user will go to SSE. It will redirect to SSO. SSO will then user will authenticate on the company login screen. Let's say IBM login screen, whatever it comes. User will log in here, like, and then it will inject a token to redirect user to SSE, and there will be mapping of the user with SSE, and this configuration is done by administrator. So there is a profile in market called SSE administrator. It's a different training altogether. So we
Okay.
can also use LDAP, SSO, or any third party identity provider. This is typically configured by basis. If you can give me your company productive system and SSO account, I can do this
Hmm.
configuration for you. But will your company allow me to access that? If they can, I can do this configuration for you.
Okay. Thanks for the information, Anubhav. Yeah.
Yeah.
But then,
So
sir,
Nochango,
the
please check your
user ID
LinkedIn.
has to
I've
be
already
created.
provided detail to you on LinkedIn, Nochango. Yes,
Sir,
Narayan.
user ID has to be created in SSE, no?
There is a generic user ID which we can use across all the business users.
Okay.
And you can actually register as many users as you want in SSC. There is no limit to that. User ID has to be
So
there in
Anubhav,
SSC.
what I understood that with this explanation that I have to go to the SSC and create the user there itself. So no
Yes.
need to specify the SSC like a tenant account,
No, no.
right?
You need to go to user
Okay.
management in SSC and create a user there, your business user.
Okay. Okay. Thanks, Anubhav.
Thank you. So there's a question about metrics. Can you please show me where logo of the material is? Logo I have not uploaded till today. I will upload it today. In confusion matrix, we have 4 quadrant, but only choose 2 good one. Yet we use all 4 quadrant to do equations. Why? Okay, because it cannot ignore the negative also. So when we want to calculate accuracy, we need to take in account the negative targets also. Basically, all these things are percentage. You see, how do you calculate percentage? Both positive and negative together, right? Both positive and negative together. That is why we are accounting also the negative targets to calculate percentage. It's a relative percentage of how many of them are correctly classified or incorrectly classified. So that is why we have to also consider the negative as well. Yes. How many percentage student passed? How do you calculate if you not take account of failed students, right? So this is why the rules, and these are standard rules of calculating the sensitivity, and specificity. These rules you can also read on Google. If you just Google confusion matrix, you will find these rules are standard. I have not written these rules, or neither SAP have written these rules for Analytics Cloud. These are general machine learning terminologies which are written years ago in mathematics to calculate probability. Okay. All right. Thank you so much, guys. See you in the next class. Goodbye.